Good evening, everyone. So today we're going to look at the how we're going to create the AWS Elastic Kubernetes Service Cluster using Terraform. Terraform is an infrastructure as code tool which is cloud agnostic and which can be used for any kind of cloud provider. Right now, we're going to talk about the AWS, that is Amazon Web Services cloud provider based EKS cluster, how we're going to create it using Terraform. So the AWS EKS cluster, which we are going to create, we should consist of an AWS VPC, that's a virtual private cloud network. Under this network, you should have the subnets. There are two different types of subnets which we are going to use. First is the private subnet, which is the underlying part here, where the EKS cluster will live in. EKS cluster nodes will be living in a node group, and it will be exposed to the public subnet group, which is a Bastion host autoscaling group, which will be used for mainly to connect to that particular private network nodes and then subnet nodes, and then deploy our load workloads or services or deployments or replication controllers, and that can be exposed to the external world as a microservice. So we should create this as a whole using Terraform, how we're going to create. So before that, we got to install certain required software in order for the Terraform to execute. So you have to install the Terraform and then put the path into the configuration, the Windows path, so that it can be invoked from anywhere. And then once we install the Terraform and configure it, and then we got to install the AWS CLI here using the Choco. In case of Windows, we are going to use this AWS CLI to be installed through the Chocolate. Chocolate can be installed using the PowerShell of Windows, and which is a standard methodology through which we can use the Chocolate. Once we install the Chocolate, we can use the Choco install AWS CLI, use this command to install this AWS CLI, through which we are going to configure the AWS configuration using the AWS configure command, which requires us to provide the certain access key IDs and secret access keys, and the region we are targeting to, and the default output format JSON, which is going to be there. So once we create any kind of resources in the target AWS, the output will be shown as a JSON file, a JSON output format. And once we do that, we got to git clone the repository wherein our EKS standard cluster, EKS cluster Terraform providers and Terraform code will be there. So we have to git clone this Terraform provider code using the git clone, and then the URL is given here, and then through which we can install or download this the learn Terraform provision EKS cluster. Then you can go to that particular folder using the cd command and change directory command to that particular folder where we download that particular code. So once we do that, so we're going to do that, the installation is done. So we're going to go to that. We're going to open that Atom ID. The Atom ID is mainly meant for the Terraform code and to execute and create any Terraform code, to modify any Terraform code. We have to use this. So if you go to this particular folder, you got to have this. You're going to have this Kubernetes.tf file, Terraform file, which shows this provider details. The provider is Kubernetes, and the load configuration file is false because we're not going to use the local configuration file. Since we are going to target the AWS EKS cluster, it should be false here. And the host name should be given as data.aws underscore EKS underscore cluster.endpoint. This is your endpoint for this host through which this complete installation is going to happen. This is a standard endpoint provided by the provider, and the token also is taken from this particular location in the AWS cluster. Excuse me. And then the cluster CA certificate is going to be a base 64 decode. We're going to decode that certificate using base 64 decode function, and then we're going to pass this certificate authority data also to in order to decode this certificate from the AWS provider. So that's about the provider information. That's for the first step, and then we should open the second module, wherein the module says the EKS is the module name, and then we have to have a source as Terraform AWS module slash EKS slash AWS. This is a module which you're going to download. It's going to be downloaded by this Terraform provider using the source location. And then we should have the cluster name. This is a standard cluster name which is provided with the localized environment. So based on the environment variable, this is going to be created. So our cluster name should be targeted with the starting with the training as prefix, and then followed by some randomly generated alphanumeric characters. On the cluster version, the version of the Kubernetes is going to be 1.18, and the subnets are going to be defined in the module.vpc.private_subnets. So that we are going to have that in the subnet in the security groups here. So where you have this AWS security groups, and then you will have this security group. Each of these worker nodes and management nodes, all worker management nodes to be connected through this specific VPC ID as an ingress using the port 822 through the protocol TCP. And the CIDR blocks are defined for the subnets we are going to create for our underlying cluster here. The cluster here is the cluster private cluster through which we are going to expose this node groups of EKS cluster. And then if you go back to this one, and if you see this EKS cluster, you can see that worker groups are going to be given here. The worker group 1, first worker group, and this is going to be a T2 micro. And then the second worker group 2, is going to be another type of instance type of T2 micro. You can change this T2 micro to T2 small or T2 large based on your requirements and the load which you're going to deploy onto this Kubernetes cluster. And then we should have this additional security group IDs that should be standard to be given to this security group in order to communicate with each other. So this should be given here. This is the standard security group IDs which we have to mention that. And then once we define that, we're going to have this cluster ID here as a name, cluster ID as the AWS EKS cluster. We're going to define the AWS EKS cluster here, and then authentication also is given through this module EKS cluster ID. And then the VPC is given here. And so we have another important thing which we're going to mention, that is wait for cluster interpreter. This is required because when we are using the Windows installations, we need to have the bin shell, actually the binary shell for the Linux. So that can be done through the git bash. So once you install the git bash, you're going to get this kind of git bash shell command line interface through which we can interact with the git bash, and then through which we are going to apply your Terraform. I'm going to configure the Terraform. We're going to initiate the Terraform and then plan the Terraform and then apply the Terraform step by step. So that's another point. And then the dashboard, the Kubernetes dashboard, which you're going to use, will use this specific service account admin user, and then which is going to be there in the kube system namespace. And then we're going to create the role binding, cluster role binding, which is required for us to operate with the cluster and to deploy our workloads as services or deployments onto the Kubernetes cluster. So for that, we need that cluster role to be created, the role reference, and then that should be associated with the role binding with the name of the service account as admin user. And the subjects are service account admin user, and this name is going to be the role binding. The binding is the same as the name of the service account which you're going to give. And then so we're going to use this versions and then vpc.tc. This is the vpc.tf, that is wherein we have to specify our virtual private cloud specific configurations. Here you have the VPC module, which has been referred there, and then we should have these private subnets, which is given here, and the public subnets are given here. The CIDR blocks are given here, 10.0.1.0 class 24. For the private subnets, when the private subnet lies here, 10.0. Um, 10.0.1 is the private subnets, and 10.0.4.0 is going to be our public subnet. Dot 4 is public subnet, dot 1 is the private subnet. So that's what the CIDR blocks which we're going to use here. And we're going to enable the NAT gateways because these private subnets have to interact with the external world using the public subnet NAT, network address translation gateway. So that gateway, through that gateway only, it has to interact with the external world. So through this IPs and then IP ranges, and then single NAT gateway as true because we're going to have only one NAT gateway which we're going to enable, and then which we're going to talk through or interact with the private cloud, private subnets, underlying private subnets. And we're going to enable the DNS host names so that it exposes the DNS host names externally. And then we should have these tags which are going to be shared, public subnet tags, and these tags are going to be used for mainly for tagging these private subnet and public subnets. And then if you go above, and then you can see the resource random string. This is for the random string generation to be used for the cluster name creation. If you see this locals as a variable here, these locals are defined as cluster name. As we have seen in the EKS cluster, you can see that local dot cluster name, that's taken from the vpc.tf, wherein we specify the training -eks as a prefix, and then the random string which is going to be generated here as using this random string source resource suffix. So that's going to be 8 characters length, which is an alphanumeric based characters. And then AWS availability zones are going to be available for this. And here we're going to provide the version number of this provider. 2.28.1 is the AWS provider instance greater than or equal to 2.28.1. And the region is going to be, target region is going to be US East 2, so which we can change it always. And these are the regions which are going to do that. And default region is pointed to the AWS US East 2. If you're not providing anything, it'll be pointed to this. So that's what this is going to be. So that's about the configuration, and then version numbers are listed down here, and then the outputs which we have to output, it's going to be generated, which need to be output for the for us to show to interact with the external world, which we need the cluster name, we need the region on which it's running, and we need the config maps, and we need the kube control configuration, which we're going to be using that throughout this module. And the cluster ID and cluster endpoints are shown here. These are the things mainly need to be output once we run the Terraform. So right now, let's get started with the Terraform init. So once we show Terraform init, we go to this particular folder where these files are existing, the Terraform files are existing for this EKS cluster provisioning. So go there and then do that Terraform init. So once we do that, it initializes and it downloads all these required installations of Terraform providers. The provider which we require is the AWS provider, which is going to be a 2.1 version here, as shown here. It's